Here are the answers to your partner test from last Thursday. Your test is tomorrow. I will not be here. Okay, question number 1. Describe the transformations from the parent function of f of t equals cosine t to this one. -3 cosine x, and that should probably be a t, and then yes. That should be a t. Plus 5. The transformations are, it's a reflection over the x-axis because of that negative. It's a vertical stretch by 3. It would be a vertical compression if that were less than 1. And it's up 5, vertically up 5. Number 2, write an equation for the sine function that is vertically stretched by a factor of 4, reflected over the x-axis that's negative, and shifted down 2. And if you wanted to do the f of t...
Why do you have a plus sign?
Huh?
Plus 2.
Oh, it should be minus 2. Yes. Minus 2. F of t equals, you can write this. Okay. Next one, let's go through these. Which ones are odd, which ones are even? Sine and tangent are odd. Cosine is even. Do you know what that even means? No? Okay, here, let's look at it again. We did odd and even. Here is the sine function. It has symmetry with respect to the origin. So in other words, see this point right here? This is pi over 2, 1. And what's this point? Negative pi over 2, negative 1. That's when you change both x and y, change their signs. It has symmetry to the origin. Even looks like this. If you were to cut, even though mine doesn't look very good, if you were to cut this along the y-axis and fold it over, it has symmetry. That's what even means. So with that said, if I asked you what's cotangent, what would you say? Cotangent.
Even.
Odd. Cosecant, odd.
Still the same.
Secant, even. Okay. Next one. What is the y-intercept of this graph? Well, if you were to graph this, it's shifted 2 up, but it goes backwards. This is going to go backwards. So that is your y-intercept, 0, 2. The domain and the range. I showed you guys a shortcut how to do this one. You could graph it if you wanted to, but you should know how to do the quick way. You're going to do 3 times 1 minus 6 and 3 times negative 1 minus 6. So this is going to be, which is bigger? Which number is bigger of the two?
Negative.
That's bigger. That's your maximum. This is your minimum. Your domain for sine and cosine is all real numbers, and that's going to be your range. Make sure when you write your range, it's in order from least to greatest. Okay? Least to greatest. Why did I put brackets with the -9 and the -3? Why do you get a bracket?
It's a range.
Because it's reaching those 2 points. Okay? Number 6. This was one of your homework problems. You have the graph. It's negative cosine, and it's asking you to tell me the interval where it's increasing. So I wrote hint graph it. So when you graph it, you have this picture from -2 pi to 2 pi. And where is it increasing? It's increasing from -2 pi to negative pi, union 0 to pi. Why am I not, we talked about this, why am I not putting brackets? Why am I not putting brackets?
Because it's continuous.
Because it's what? What's happening at negative 2 pi? It's not increasing or decreasing, it's a minimum or a maximum. Okay, so you don't include those, you use parentheses on this one. Questions? Okay, these ones. And on your homework from Friday night, you have a whole page of these to practice. I gave you a whole page of these right here. Okay? How do you do these? Well, here's an easy way to do them. I would make a unit circle. Let's run through these angle measures. This is 0, pi over 2, pi. This is 3 pi over 2, and this is going to be 2 pi. Name the quarter ones. 1/4, and I'm not going to write pi. You know it's pi, right? 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. Let's do a 6. 1/6, 2/6. Can you rewrite 2/6? 3/6, 4/6. Can you rewrite 4/6?
Yeah.
5/6, 6/6. What's this? 7/6, 8/6. Can you rewrite 8/6? 9/6, 10/6. 11/6, and 12/6, right? Now, in quadrant, now let's talk about this. See these right here? What quadrant is this in? 1. And in quadrant 1, they're all positive. Okay, what about this quadrant right here? This quadrant is quadrant 2. In quadrant 2, sine is positive. The other two are negative. In quadrant 3, tangent is positive. The other two are negative. And in quadrant 4, cosine is positive. The rest are negative. So if you remember, all seniors take calculus, or all students take calculus, that'll help you. So what you're going to do, bless you.
Thank you.
You're going to look at, see the word sine means what? Sine means what? Opposite over hypotenuse. So what I told you guys to do is ignore the negative for a second. Draw a triangle in quadrant 1, because you want to know if it's pi over 3, pi over 6, pi over 4. What angle is it? Well, root 3, if you put root 3 on this side, this is a 60-degree angle, which is pi over 3. Now, you're going to look at that. What two quadrants is the sine ratio negative in? It's negative in quadrant 3 and 4. So you want, go back to that circle. You want that triangle that has a 3 in it, in the denominator, in quadrant 3. You want the 60-degree in quadrant 3 and quadrant 4. So what are those two answers? Yeah, because what you're doing is you're drawing a 60-degree angle in quadrant 3, so you're measuring this angle right here. So you're putting that 60-degree angle in here, and you're putting a 60-degree angle in here. So you're measuring this angle, which is 5 pi over 3. And then don't forget to add 2k pi. Now for the cosine and the sine one, the ones that are this, sine, cosine, if it's a 0, a 1, or a -1 for these ones, sine or cosine, where are you at? Here, 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 or here. So what you have to do is look at not only where the number that you have here, but you have to also look at the word. If it says sine, sine is what? y over r, whereas cosine is x over r. So for that one, it said, the question is cosine is 0. So you want to know where the x value is 0, 0 over 1. Where are the x values 0? Here, pi over 2 and pi, and 3 pi over 2, plus or minus 2k pi. So if I would have said cosine, where is the x value negative 1? At pi. So this answer would be pi plus or minus 2k pi. You get it? Next one. Tangent. When you have a 1 here, that's a 45-degree angle. Where is tangent positive? It's positive in quadrant 1 and 3. So it's a 45 and a 5 pi over 4. Now if you want to write them both separately, plus or minus 2k pi, but tangent, you could shorten this one. If you wrote pi over 4 plus or minus k pi, you're actually okay for both answers. You only have to write one for this one. So either write one with k pi or write them both separately with 2k pi. I'll take either answer. Huh?
I thought one wrote k pi was one.
You write, the reason why you write k pi for tangent is because the period's every pi.
Okay.
And if you think about it, watch this. If you added pi to pi over 4, what do you get? You get 5 pi over 4. If you were to add 1 pi to this, you get 5 pi over 4. So you'll pick this answer up by writing k pi. But if you wrote pi over 4 plus or minus 2k pi, you're not going to get 5 pi over 4. You're going to get, if you wrote pi over 4 plus 2k pi, you're going to get this answer. And then you're going to get the one that goes around again, and then around again. You're only going to get this answer. There's this answer too. So if you write pi over 4 plus or minus k pi, you're going to get this answer. And when you add pi, you're going to get that answer. And then add pi, you're going to get this answer. You're going to keep getting them all. So you could do that. Only for tangent. Only for tangent. And then for cosine 1/2, I wrote adjacent over hypotenuse. This is again a 60-degree angle. And where is cosine positive? It's positive in quadrant 1, so that's one answer, and in 4. What's the angle in quadrant 4 with the 3? It's 5 pi over 3. So these are the two answers for that one. Questions? Okay, these ones I am asking you to write the equation. You've got to know if it's a sine, cosine, tangent, cotangent, cosecant, secant. And you've got to know not only the amplitude or the steepness, but the shift up or down. So this is a shift 3 down, and since it started high, it's a 3 cosine x minus 3. And I wrote that, but some of you guys did, I mean, that's good, like that. And if you didn't write that, that's fine. So this one, and I should have it, if I'm using t, I actually should use a t here. Why is this a -2 tangent? Well, why is it a tangent? First of all, because the asymptotes are at negative pi over 2 and pi over 2. It's a shift 2 units up, and it's a backwards, it's a negative, looks like a negative slope, so it's a negative tangent, and the steepness is 2. If it were going the other way, it would be positive 2 tangent. Number 13 is an upside down, and it's broken right in the valley, I should say. It's 2 up, and it's an upside down. It's a 3 amplitude. It's an absolute value sine 1. And number 14, what you're going to have to do on 14 is you're going to have to insert the sine or cosine for this secant and cosecant graph to figure out if it's which one it is. This one is a sine graph, so you have to know the reciprocal of sine is cosecant. And it's an amplitude of 3. So make sure you can fill in that graph. Number 12. Now, I just wanna let you know, I gave you 8 of these graphs because it was a partner test. I am shortening this test tomorrow. I'm shortening it. So, but I'm going to give more points for each of these. I'm expecting nice graphs. These are probably gonna be worth 4 or 5 points. I wanna make sure you understand that they're asking you to only graph it from -2 pi to 2 pi. That means stop right there. You should not have anything after 2 pi or -2 pi. So some of you guys are gonna continue on, you're gonna wanna continue this period, but it doesn't want you to do that. It only wants you to graph from here to here. Okay, no more, no less. If you graph more, it's wrong. If you graph less, it's wrong. I'm looking for the asymptotes need to be broken lines. So if it's a tangent graph, the asymptotes are at -pi/2 and pi/2. And make sure you do your shift up. And make sure your graph has these dots too. I need to know that you understand the steepness. Number 13, you're gonna graph the sine curve shifted 2 units up and an amplitude of 2. So it's gonna go down 2, up 2. So this is very lightly is the actual sine curve. And then where it hits the 0 are your asymptotes, broken lines, and in between are gonna be your little parabolas. So you should see a contrast between these 4 parabolas and the vertical lines. Some of you guys didn't do that, you drew straight lines. You're gonna lose a point for that. Number 14 is the sine curve. What's the difference, absolute value of sine and cosine? How do they differ?
One starts on
One's
the origin,
down.
one starts on the
Robbie, say it again.
One starts on the origin and one starts above or below it.
This one is absolute value of what?
Cosine.
This is cosine. And then this one, sine would be like that. So make sure you know the difference. And again, I wanted you to graph it from -2 pi to 2 pi. Done. There's no asymptotes for this one. Number 15 is a shift 2 down, and it's the cosine graph, so 3 down. So it's gonna go, it starts down 3, and on, above, on, below, and notice how I stopped right there. Number 16 is shifted 1 down, it's the sine curve, 2 up, on, above, on, below, on, from -2 pi to 2 pi. (17) What's the difference between tangent and cotangent? What am I looking for? Asymptotes. Asymptotes for cotangent are at 0 and at pi. And cotangent looks like a negative line. Now, what if there was a negative in front of here? Then it would look like a tangent. Okay? Questions on that one? (18) You're gonna graph 3 sine t minus 2. And right here, very lightly, is 3 sine absolute value. And then so your asymptotes for this one would be in between. So these are the actual graphs for that one. And number 19, this is what the absolute value of the tangent one. Normally it would look like this, and by the way, this is 2 up. Oh no, yes, 2 up right here, and the steepness is 1. See, normally these would look like this. This part would be coming down here, but because it's absolute value, this piece that's here, it's going to go up. This piece from here is going to go up, so that's why these are looking like this. And notice how I stopped right there. And that's to show you that I'm only graphing negative 2 pi to 2 pi. Now, if I had a number in front of the absolute value like 2, it would be going up to 2. The steepness would be 2. So tomorrow's test is going to be shorter and sweeter. It's going to be same number of points, but a lot shorter. I gave you a longer partner test because you're working on groups, and I wanted to test you on every single kind. But tomorrow's test, it doesn't have to be as long. But I am going to look for quality, not quantity. I am looking for perfect graphs. Very neat. Use a pencil. Some people like to bring like a marker, and they like to do their asymptotes in a different color. That's great. If you can do that, that's awesome. Anybody have any questions? That's your partner test. So tomorrow's going to be your test, right?